Okay. Okay, good evening and thank you for joining me. Well, actually, Happy New Year, everyone. Just want to wish everyone a Happy New Year. And yes, I have not actually looked at this model. I want to be like on top of things. So like hour 40. Let's go hour 40, right? Or should I say 42? Actually, 36 was the one I was looking at. Looks deeper. Looks a little bit deeper now. Definitely looks a little stronger. Let's go to 42. This is what I wanted to show you guys. Okay, see? Oops, Mid-Atlantic, not the Northeast. Look at where the precipitation ends. Look at the center of the low. Basically a 996 millibar low right over Cape Hatteras, 996. So you're having it being a little further north now. Look at that. It shifted even further north. It still doesn't look like a lot of snow for New York City. It still doesn't, but it's a major, major change. Actually, not that major, but a lot more precipitation on its northeast side, like a lot. This is a major snowstorm for Virginia. Like, this is going to be feet of snow. This is going to be like at least a really, really major storm. So let's look at our 40. Let's look at 45. So see, even though the green is still over New York, but look how much closer the heavy precip. I mean, look at Atlantic City. It's getting like ridiculously heavy snow. Like, this is really, really heavy snow. I mean, look at this. Like, this is ridiculous. Like, this is going to be a real snowstorm for like Philadelphia, Atlantic City, New York City, a couple inches of snow. But as I said, this is going to be further to the south. I mean, look at this. Look at the 18Z run showing a foot to a foot and a half of snow for some areas. This could still shift further north because look what the SREF been showing. Still waiting for the SREF, but look, this is what was shown last night or just a couple hours ago. You know, not much, right? And then 21Z and bam. Heaviest amounts right across southern New Jersey. A major shift to the north. And look at 8+ inch probabilities even going into New York City. So the thing is, but your highest chance of 8+ looks right across coastal New Jersey. The thing is, it could still, like, New York City might not get much at all from this. But the thing is, the models have definitely shifted further north. This doesn't look like it shifted further north. But let's look at the last one. So this is hour 42. Major, major change north. In fact, I've been looking at the other models and I was shocked at how much further north some of the other runs have been going. So let's look at 21Z, right? Showing a cutoff flow going across New Jersey and then, you know, North Carolina and then out to sea. Basically, that would keep the system further to the south, right? Keeping it right across coastal New Jersey. I mean, yeah. But that's 21Z, right? And that is right around hour 47. When you go to hour 0Z, it cuts off to only 20. So, again, let's compare. This is hour 32. Now let's look at 0Z, right? Or 3Z. Also, it looks stronger, a little stronger. Let's look at the amplitude here. Very, very deep amplitude. But you also want to look at the flow to the north. It looks like it's a little bit more to the northwest, right? So you're having a northwest flow. And it goes northeast, even though it's... So the other runs, here's the thing. Here's why the GFS shows a cutoff low that tries to kind of, you know, merge back here. So there's still a chance it could end up going further south, but it's this little piece right here, this little piece. Right there. You can see this trough at 200. So this is that piece that's going to force the storm to go further north. Right there. So, because the heights are decreasing in the winter. So like your 500 millibar temp or heights have always decreased in the winter because cold air sinks, warm air rises. So as warm air rises, your heights increase. The thickness of the atmosphere increases because of warmer temperatures. When you have colder temperatures, you get lower thickness as the atmosphere shrinks. You might have higher pressures at the surface, but actually there's less air above your head. It's a little, but there's less air, but it's not how much air is at the surface, but how thick the atmosphere is. You can still have higher pressures in colder weather because cold air sinks, and because it's sinking, because there's more sinking air, there's less space above you. So air takes more space at the bottom. So there's more, so it's all like congested at the bottom. So you have all the air at the surface. So there's less heights above. So you can have very high pressure in hot weather, but that wouldn't decrease the heights. It wouldn't, because it's so hot. Warm air still rises, and so hot air rises, cold air sinks. You know, if you ever look at a fluid, if you were to have the fluids at different temperatures or saturations, you'd notice how, you know, even water, even the Gulf Stream, that's a flow of hot water. Fluids of the atmosphere behaves basically like a fluid. That's why they sometimes use fluid models to simulate weather. Anyway, let's look at the the RAP again. So again, the heights are stronger. See, it's right around Georgia, right? But here it looked like kind of a zonal west flow. Here it looks like a little, like it's trying to kind of, see, you're kind of having a southwest like flow right here. So you might be forced to go up further north, especially here. See, having a west-east flow is a very zonal flow. Here, a little bit shifted. It shifted a little bit. But of course that's because of the Coriolis effect as well. See? Look at those wind barbs. See, there's definitely a little bit of a change, just a little bit. But that little bit, let's go out 4 hours. See how it's over North Carolina? Probably will be around North Carolina, but let's look at 3Z now. Around the same area, but look. See, it kind of tries to go further north. Look at that. See? You probably don't see that on the last run. In fact, it was a huge decoupling, right? It was a decoupling, very weak. Like, it didn't look that strong, but here, there's still room for it to try to go up. Look at that. That does not look like a big change. In fact, it does look a little major, but look, let's go to our 40 again. Right? But now let's go at 3Z. Boom, further north. Now let's look at this. Again, moderate to heavy precip just south of New York City. Like literally, this looks like the Snowmageddon where New York City was right at the cutoff. Like boom, cut off. Like so close, but no dice. That is going to be at least, that's going to be like a 10-hour snow, like a really quick hitting storm. Bam, and it's out. But that's going to produce a lot of precipitation. Wow. Really quick hitting snowstorm. Like boom, and it's out of here. So that's boom. And And that thing just could shift just a little further north. Next run in New York City is going to be soft and snow. Or it could still shift further south. But there's a trend now with the models going further north. Look at Philadelphia. Look at the Atlantic City getting a foot to a foot and a half of snow. Look at some areas getting 16 to 17 inches. And that's using a 10 to 1 snowfall water ratio, which is not accounting for the dendrite growth zone, which I'm going to be using. The Kuchera method uses the dendrite growth zone, which is about 700 millibars or 10,000 feet. This is usually more accurate. So look at that. I'm still looking at a good 13, 14 inch snow event. But this is what you really want to be looking at, is the Kuchera method. Or Kuchera method is the most accurate. I usually pronounce it Kuchera, or it's either Kuchera or Kuchera. Of course, depends on where they're from and the way they pronounce stuff. I haven't really looked at the GFS run. I think I have for that Friday snowstorm, but that's the Monday event, and here's the Friday event. Oh, wow. Out to sea as well. Yeah, that's going to be a bummer if that actually happens. See, but look at that. Major cold event, and then another snowstorm. So see, it's going to be a really stormy next few weeks. Yeah, with all these major Arctic outbreaks happening, for the next couple weeks, we could see snowstorm after snowstorm after snowstorm. It's going to be a really stormy next few weeks, just to say the least. January is going to be really stormy. It looks like it's going to just be a lot of snow next few weeks. A lot of chances of snowstorms. Yeah, I did not see this happening at all. I'm gobsmacked by this. I'm completely just at a loss. The fact that the GFS is forecasting this, I'm okay. And the thing is, the Euro was showing the storm bulldozing New York City. So, yeah. So there's still a chance of a major storm. We could be getting not one, but two major storms in a row. And if we do get a third storm, it's going to happen after quite a bit of melting. You see that? We're going to get into some warm weather, and then it's going to rain, and then we could get another cold blast. But that's looking towards the middle of the month, basically. And being this strong, if this storm is going to be in the 980s, it's going to definitely pull down some cold air. So, yeah. That's just the GFS. So let's look at the ensembles. So yeah, again, looks like things have been trending further north. Let's look at the 18Z. Further south. Further north. So yeah, quite a bit further north too. Well, not a lot further north, but let's look at ensemble precipitation accumulation. Let's look at Mid-Atlantic, 18Z. The one that shows a major snowstorm, the big one, is ensemble member 18. That is one big storm. That's at least a foot to a foot and a half of snow right there. That's the most major one. Ensemble member 18. There we go. 18. Most of them keeps New York City getting very little to no snow. Little bit, big storm, nothing, little, nothing. The thing is, in fact, during Winter Storm Janice, back in 2016, it was around 24 to 36 hours before the storm hit that everything shifted further north. So this is 18Z. So let's look at ensemble precipitation accumulation now. Again, most of the runs are shifting further north. Well, it was only one that showed a really significant storm. One significant storm here. you're getting further north, but right here, see? Big storm on the 7th, right? And then close call, so it's still one run. So it's pretty safe to say that southern Jersey, Virginia is going to get completely clobbered by this storm. It's pretty safe to say. Ensemble number 7 is the biggest one here. But the thing is, all of the models here, almost all the models are showing New York City getting a bit of snow. And then, Friday, and then you're going to get basically the Friday event. Oh yeah. Mean snowfall accumulation. So again, a shift further north. Not a major shift, but nevertheless a shift. And then bam with that Friday storm. So looks like the bullseye is going to be right just north of Richmond. Richmond to Delmarva to just south of New York City. Okay, let's look at the HRRR. This is, okay, that's lake effect snow in Chicago. So see, that is precipitation with lake effect. So they're showing Chicago getting lake effect snow right now. I'm currently looking at Chicago on the satellite imagery. I'm looking at KLOT. There really isn't any lake effect snow. In fact, most of the snow that's coming down is coming down from the system, not from lake effect. In fact, there's very little lake effect snow in Chicago. There's very little. There's one band that is very weak light snow that's impacting Glenview, Rosemont, going down to Bentonville, but it's very light snow. It's like flurries, basically. I'm looking at Tilt 2, and it's like barely even there. It's like the clouds barely extend above 4,000 feet. Yeah, in fact, it doesn't. The snow that's lake effect is only when I look at the lowest tilts, like below a couple thousand feet, there's some snow reaching the ground. So there's some light snow, lake effects, enhanced snow, that is just west of Glenview. That's over Glenview, Winnicott. Even though the band has left, one of the bands have left, there's some more snow coming in from the west. Light snow. There's some snow impacting the Quad Cities right now. Davenport, Moline, East Moline. So the Quad Cities are getting some snow right now. So it's Davenport, Rock Island, Moline, and Benendorf, but the big city is Davenport. That's the biggest city of the Quad Cities. And yep, flash flood warning has been issued. Literally not surprised a flash flood warning has been issued for my area, because we had all that rain, literally about there's been close to about, as I said, 1 to 2, like 1 inch of rain that fell at a very short period of time that prompted that flash flood warning. It was about an inch. Some areas near Trenton got closer to like 1.5 inches of rain. Actually, wow. Some areas near just west of Charlestown, Pennsylvania, near Kimberton, Pennsylvania, there's been some greater than 2-inch amounts. Hopefully there's no flooding there, but yeah, that's a lot of rain. And there's still some rain heading my way, but it's light rain. It's just light showery rains now. The heavy stuff has already bypassed us. That was basically the cold front that came through. it had some severe weather with it. Around the DC or Baltimore area, there was some severe weather near Glen Burnie. And along there were special marine warnings issued near Annapolis. So I'm just waiting for the other runs to come in. So again, I'm also going to look at Europe. I'm not just going to look at New York. I'm also going to look at Europe because I also focus not just on like local weather, but national as well. So here's that big trough that's basically kind of going to be traversing the country. And that trough is going to set up our storm for the weekend. So the Euro model is showing a very, very deep trough. Like really deep. And then it shoves it off the coast. But that looks rather weird. Okay, that just looks weird. So you see that really powerful, like really strong just jet here, that 500 millibar jet, very strong. Let me just log in. There we go. Let me see what I was looking at before. Okay, there we go. You're having that really strong jet, and yet it completely falls it apart. It just doesn't make sense. It just doesn't make sense. Yeah, look how far south the storm is compared to the like 18Z run. 18Z run is a little further north though, but not by much. You really want to wait for the 0Z run. But yes, there has been a shift further north. Not a major one, but yeah, a small one. And it shows some late precip for coastal New Jersey. But let's look at total QPF. You want to look at total, or 24-hour QPF. Very little snow for New York City. In fact, the winter weather, let's look at total. But it is still more than the 6Z run. Again, more than 12Z, more than and it is shifting further north. That's the one model that's shifted further north. Now let's look at the GDPS, the Canadian, of course, better known as a Canadian. Wow, further north, everything's trending further north. So, let's look at the National Weather Service blended models. 30. Surface and precipitation. Let's look at hour 48. Let's look at hour 12Z. Let's look at total QPF. Yep, so even the National Weather Service blended models is starting to pick up on that snowstorm. And look at that, some of them are even showing snow in the New York City area. See that little line? See the axis of heavy snow will be across the Jersey Shore into the northeast area. Yeah, it is starting to move further west. So there is definitely a trend north and west. Not a major one, but there is. Alright, let's look at the wrap. I already looked at the wrap. In fact, it updates every hour or so. But the 3Z is usually the most major run. So you got a 3Z run, and then you got the 21Z run. Those are basically your major runs. Let's look at 6-hour QPF. Let's look at 1-hour QPF. Oops. 30. So yeah, there is definitely a shift further north. Let's look at 6-hour QPF now. 6 hours. Bam. Let's look at 12-hour QPF now. Bam. 24-hour QPF. Or, yeah, there you go. And if you change that between, last 21Z and 3Z, there's a major shift to the north. And this, in fact, was happening during Winter Storm Garrett. Where do I think the heaviest of precipitation will fall? Well, I think the cutoff should be just south of New York City, Trenton. I do think New York City will get some precipitation, but it'll be light. I don't think it's going to be super sharp because there isn't that major jamming high that's going to try to shift everything to the south. It's basically the position of the storm that will determine how much snow falls, not how much dry air is in places. This is a little different than what happened back in 2010, or January 2010. This is a slightly different setup. Plus, the ocean is very unusually warm, which could give the storm a major boost in intensity, and that tightening up could cause the low pressure system to go a little bit further north and west. So let's look at Sst Anomalies. Oops, I did not want to look at that. I want to look at current Sst Anomalies. So let's look at current Sst Anomalies. Yeah, look at all that warm water. Jeez Louise. Wow. That is off the charts. You're having La Nina, you're having cold water here, well, warm water here. You're asking for a blocking high. You're asking for a very, very stormy winter. You're asking for all this Gulf and Atlantic moisture. You're just asking for trouble. You're literally asking for trouble looking at this. You're like begging for it. Yeah. You're begging to be buried under feet of snow with a setup like this. I mean, if it's not going to be for the rain changing to snow changing to rain because of all this warm water and having a really strong Arctic outbreak and a storm forming along it, you're asking for just a major thumping of snow. Yeah. And I knew this year was going to be major. That's why I said I'm calling for 40 to 60 inches of snow for New York City. And I didn't change my forecast. And you know what? I am not changing it. I am still keeping it as 40 to 60 inches. Because guess what's going to happen in January and then February and then March? We're going to be hit by snowstorm after snowstorm after snowstorm, nor'easter after nor'easter after nor'easter. Why? Why am I thinking this? Even though you're not having a positive PNA. Because you're going to have a blocking pattern developing. You're going to have a lot of cold blasts. You're going to have a lot of, you're going to have intrusions of Arctic air because of the La Nina, and storms will be forming along the coast and just shooting up and riding up the coast. This is a perfect setup for major winter storms along the East Coast. La Nina, very warm Atlantic, major snowstorms every time. 95, 96, 2009, 2010, 2011, same thing. And then when this area cooled off and this became cold, you had La Nina and you had a cooler Atlantic, you really didn't have any snowstorms. And also you didn't have that warm tongue here right in the Gulf of Alaska. So that is why we didn't have a lot of snow in the 2011, 2012 winter season. And I'm going to also ask something else. why did we not have a very snowy winter during the winter of 2019-2020? What changed? Why was the winter so unusually not snowy? Well, you can thank a little volcano in Alaska, in the Kuril Islands called Raycock, which basically strengthened the polar vortex. During the 1815 eruption of Tambora, the winter was unusually mild. The winter itself was very mild, but the spring and summer was very cold with snow. In fact, the winter was about the same as the summer. You had a very warm, mild winter, but had a very cold and snowy spring and summer, completely flipping the seasons on their head. And we kind of had a similar effect. We had a good amount of sulfur that came from that VEI4 to low end VEI5 eruption. Changed the sunsets. It made the sunsets really beautiful all over the world. I actually have photos of it. I still have some photos of it on my phone. And yeah, it was beautiful. It made the sunset purpley and just blue. It made for really beautiful sunsets all over the northern hemisphere. Even in Florida, like, it was everywhere. I mean, I think that eruption was not a VEI4. I think it was more likely a 5. I think that eruption was underestimated. The amount of sulfur that was emitted by that eruption was very, very high. It was more typical of a VEI5 eruption than a VEI4. I think the eruption of the Raycock volcano was probably right on the cusp of being a 5. I think it may have even been a 5. The only reason they consider it to be a 4 is because the eruption column wasn't sustained. It wasn't a continuous eruption that lasted for days and days, but it was a very powerful eruption that lasted for maybe a couple hours. So I do think it was about a high-end 4, low-end 5, but that's why New York City had snow May 9th. Because it strengthened the polar vortex for most of that winter and trapped all the Arctic air basically in the Arctic. And actually, that was some good news for Arctic ice. It allowed the cold air to stay in the Arctic and not, go south. Even though the Siberian signal supported very cold and snowy weather for the Northeast. And even the Atlantic, even the water temperatures, everything looked perfect. But the volcano kind of tripped everything up. That one little volcano changed the whole equation for that winter. It was the volcanic eruption that changed everything. And it was a pretty powerful eruption. I mean, climate change is also making a big impact on weather patterns. And Dr. Cohen, who is in charge of, who makes those forecasts, who found a correlation between Siberian snow extent in October and major winter storms in the East Coast, said that climate change is starting to change that correlation. And of course, that winter you had to have that volcanic eruption that occurred basically just as COVID was starting. Let's go back and look at the forecast. It did. Yeah, I actually did. I definitely saw that. And I'm now just waiting upon the Euro and the Canadian. I'm looking for the CMC to come out. Let's look at, this is what I wanted to do. Yep, and this is not the only run that is showing that. Yeah. Major Arctic outbreak. Wow. Woo! That is some major Arctic air. Wow. Like, it's gonna get cold after that, system we're gonna have on Monday, but then all hell is gonna break loose the second week of January. Bam! Second week of January is gonna be bitter. It's gonna be bitterly cold. Oh my God. And I should have mentioned this. Bitter cold. Like, this is gonna be some real cold. Let me go back to pivotal weather and look at temperatures because that is some major cold. Let's look at 2-meter temperatures. Yeah, that is some major cold. That is going to be like, wow, look at those temps. 11 degrees in New York City, and let's see what time of day that is. Let's look at yes, regional, local, southern New England. Wow. Oh, wow. I mean, this is not record-breaking, but still, it's really cold. This is Eastern Standard Time, so this is 1 a.m. and this is 7 a.m., so yeah. This is 24 hours earlier, and then Arctic front comes in. Let's see how it comes in. So you're going to have an Arctic front obviously coming in, right? Comes through completely dry. Or, yeah. Oh, that's the Arctic front. Comes through with a tiny bit of precip 5. And then comes the Arctic air. And then the horn gets blown and it just floods in. Let's zoom out a little bit and let's look at regional. Let's look at the Northeast. We're looking regionally now. Let's look at the heights. This is what I want to really look at the heights. So look at the 516 line or the 510. This is what is true Arctic air. This is, New York City's been inside that line plenty of times, but it's usually happens January, February, which is approaching now. But look what happens to the 510 line. Bam! It's collapsing south. New York City has never been like this is the 510 line. The Great Lakes are going to be completely just engulfed in Arctic air. Look at the 492 line. It's still going further south. This. Oh my God! I think it's the next morning. I think the following morning. I think the morning of January 12th is going to be bitter. Really, really bitter. This is going to be record. Interior areas are probably going to break records. There's going to be records broken. Some places. I'm not sure about all-time records, but daily records will absolutely be broken. But state records, all-time records, no. I don't think all-time records will be broken. I mean, of course, with the urban heat island and everything, you're probably not going to break any all-time records. It might come close in some areas, but Great Lakes are probably still not. It's probably going to take a couple more weeks of this to freeze most of the Great Lakes over. I mean, we still could have. There's a chance we could have a winter like 2014, 2015, even though the PNA is not going to be positive. The La Nina supports blocking patterns and cold air intrusions like this. Yep, this is El Nina. This is La Nina doing what La Nina does usually for the Northeast. La Nina usually likes bringing Northeast cold weather. You got two types of weather patterns that snow lovers love. That is a moderate to strong La Nina and a weak El Nino. Well, for some reason, both support blocking patterns. You usually get blocking patterns with certain types of El Nino and certain types of La Nina. And these are the types of La Ninas that people love, snow lovers love, especially if you have a warmer than normal Atlantic, which we're having right now. And of course, this is probably going to cool the coast, and you'll probably start having below normal temps. I would say by the beginning of February, or even by the middle of January, we might have a sliver of below normal temps along the coast because of all the cold air funneling over the very warm waters. And you're probably going to see a boatload of ocean effect snow. There's going to be ocean effect snow galore. If you're in a boat here and you're having this crazy cold temperature, you're probably going to have snow squalls after snow squall after snow squall, or just a bunch of snow coming over. Ocean effect snow. So there's going to be a lot of snow. I haven't seen ocean effect snow in a long time. Like one time, the ocean effect was so intense that it was almost reaching the coast. Like it was intense enough that in the cloud you could actually see the snow bands forming in the distance. Even looking from land, you could see the snow falling in the distance. There was this one day where there was enough cold air that there were snow bands coming in, and there was ocean effect bands falling off the coast. So I thought that was ocean effect snow that was coming on land, like it was kind of back building, like outflow boundaries. But no, there was a little bit of a system coming through. This was back in like 2002. This was, I believe, January 2002. This is the winter of 2002-2003 that gave New York City so much snow. The first time New York City had over 40 inches of snow since 95-96, which broke a record. It's actually New York City's snowiest winter ever, and it happened during the La Nina. It happened during a very similar setup where the Atlantic was very warm. You had a very warm Atlantic. You had a strong La Nina. Basically, the winter of 95-96 is similar right now. It's similar. This winter is similar to 95-96, except that the Atlantic's even warmer, and the Pacific, and this La Nina is just as strong. But pretty much things are the same, except that, again, climate change has changed some things. So, but yes, the setup is very similar to 95-96. For those who follow meteorology, this is a very similar setup to the winter of 95-96. And also similar in some ways to the winter of 2010-2011. That had similar setups as well, with coastal storms riding up the coast very quickly. So yeah, basically a very similar setup. Anyway, so the fact that the setup is very similar to 95-96 is very reminiscent, not reminiscent, is very supportive that January and February will be very snowy for New York. And let's look at teleconnection. I'm just going to show you what I'm talking about. We're going to look at the PNA and the NAO, which were both very negative at that time. Let's look at teleconnections. Let's look at the NAO index. See, it is trending up, which is weird considering they're forecasting so much cold. Looks like neutral conditions. There's some blocking here. So your red is blocking, so there's no block. So there you have it. Strong blocking over. There's some strong blocking in Europe, though. There's Greenland. There's the East Coast, and yes, there's some pretty strong blocking over. Yeah. anyway, yeah. I'm just sitting here waiting for the European model to start its update, basically. I don't really have anywhere to go, tomorrow, or should I say today, for me in New York, so I'm going to stay up for another hour or two, live streaming. I mean, honestly, I do hope that eventually the channel, the Weather Hub will be a channel, not that I'm going to be only doing this, that anyone could basically, make their own forecasts and upload. I want to kind of make this like a team channel. I don't believe in single ownership, but co-ownership. So, like, not even that, like, so anyone could, like, upload, but not, like, delete the channel. But of course, I do prefer this channel stays more like on the download. I'm mainly doing this channel to build up my resume, so when I graduate college I can get a job as a weather forecaster for a local TV network. So this is more for like a repertoire thing. This is not to become popular on YouTube. This is more for my future career, which probably will not start for another few years. I've kind of been dealing with a lot of personal issues, both because of my disability and COVID. COVID kind of put a fork in my plans of going to college, so I took taking a few semesters off. And I also cannot take full-time classes because I'm going to put this out there. I am on the autism spectrum, for those who do not know that, and also suffer from several learning disabilities. And also, I went to a special education school instead of a regular public school because I was severely bullied, and it was made in my best interest that I should not be in public school. No, I didn't have any issue. The issue was, unfortunately, that I had really bad PTSD. That was the major issue. And I refused to go to school because I feared for my personal safety. That's what really happened. And yeah, I did sustain some injury, like physical injuries as well as mental. And surprisingly, the worst of the bullying was not in my classroom. No, it was actually in the special ed department. It was in the inclusion program that all the bullying happened. So kind of ironic if you ask me. Place that you're supposed to actually be in, like, safest places was actually the worst place. And there was this toxic person there that made everything just worse. Just was a really all-around a bad person. I thought, yeah, that person was just all around not a really good person. But don't get me wrong, I wasn't innocent either. I was kind of like feeding into the situation instead of trying to get away from the bullying. I was just always asking her to like punish the bullies, but of course she never did because apparently she didn't like what I was or the way I was handling the situation. Yeah, I'm just rambling. You know what? Time for that to stop. So now I was getting off on a tangent again. Let's focus again on the weather, and basically let's look at the weather for the next couple of days for New York City. So here I'm making a forecast without looking at the models. I'm going to make my preliminary forecast based on what I saw so far. My forecast for New York City is today will be cloudy with some rain early, then clearing, Highs will be in the mid 40s, falling into the upper 30s in the afternoon. Monday will be mostly cloudy in the morning with snow developing in the afternoon. Most of the heaviest snow will be to the south. Forecast is still subject to change. As of now, I am forecasting 1 to 3 inches of snow as of now. But I'm still waiting on the European model to come in, which will determine whether I should change it or not. But I'm expecting 1 to 3 inches of snow as of now. And I believe the Euro will probably show 1 to 3 inches. This is not my official forecast, and it could definitely increase or decrease. And for the Friday event, I am forecasting 2 to 4 inches of snow. There have been some changes in the models lately that are leading me to believe that the Friday event will not be as big as forecasted. In fact, the storm for Monday might actually be the big event. I don't think it's going to be the biggest storm of the year, but I do think it may be the biggest storm we'll see for the next couple weeks. And my only hope is that when I go to Europe with my friend, which will be a mechanic trip, we're going to Europe mainly to go to Campi Flegrei in Naples. That's the primary reason for the trip. And I'm thinking about getting a SIM card so I could still live stream and surf the internet and call while I'm in Europe. So yes, there's actually a SIM card that you can use for all of Europe. That's a good thing. So, okay, I'm eating now. So yeah. Chances in Nashville tomorrow. I would say about 5 to 6 inches of snow. But definitely more in Virginia. Virginia is going to get completely clobbered by this storm. Yeah, Virginia is going to get slammed. Actually, yeah, most of your snow will definitely fall tomorrow. As I said, but total piece of accumulation. Yeah. Let's look at 6 hour. I should probably be looking at the weather.com, which will give me more accurate. Let's look at 6 hour precipitation accumulation. There you go, Nashville. I wouldn't say more than 6 inches. So yeah, I think 6 inches for Nashville is a pretty good bet. Like 4 to 6 inches. Here's Nashville right here. There's Nashville right there. Man, so yeah, 46. I would. Oh man. And the website just shut off on me. Let's see if it's the website or if it's. Please tell me it did not. Okay, it looks like. Okay, looks like it was not the internet. Okay, the internet's still on. It looks like the legacy page stopped working. Okay, let's go to pivotal weather now. Okay, legacy's down. Great. I don't know. Maybe it's just. I really hope they're not taking legacy down. Legacy's a lot easier to use, to be honest with you. Well, I found it easier to use. Well, looks like I'm gonna have to get used to legacy now. I mean, the new one. It looks like the whole site is down. Yeah, it's not just legacy. It looks like the whole site is crashed. Okay, moving on. The European is now coming in. The Euro model is now starting to come in. So you definitely got a stronger upper level system here. Yeah, you know what? Pivotal weather. Screw it. I'm going to pivotal now. United States, national, continental U.S. Let's take a 2 meter temperatures. Okay. Upper level, height vorticity. There's your 549, 546. Wow, definitely deeper. Yeah, you definitely have a deeper trough here. See, your 546 here was right on the border between Kansas and Oklahoma, just dipping a little bit into Oklahoma, but now it's dipping almost into southern Oklahoma, so definitely deeper. Definitely a deeper trough. Almost like a 45. So very deep. Looks like a 580. No, not a 580. 558. A 555. Yeah, 555 right there. See. But look, cut off 555. Here, 552, even deeper. Yeah, it's even deeper now than the last run. Still 555, and then bam, 552. Yeah, this looks insane. And let's see where it is. It's also further north. Look at that. Huh? Oh my God. Whoa. 549. Is that what I'm... that's a 549. That's a 549 level. Jeez. Again, 549. Wow, that is deep. That is deep. And let's look at the flow starting to, let's see, let's look at the flow. Yep. Let's look at the GFS at the same time. Where would the GFS have the system? No, the GFS looks more impressive. But the thing is, But it ended up off the north. It's going into Virginia. Oh, that changes a lot. That did not go into Virginia. In fact, it went off the coast. Going into Virginia is like, okay. Even the GFS did not have it going into Virginia that early in the game. Did it? Did the GFS have it going into Virginia? Even the midnight run? Let's see. Yeah, kinda. Looks like everything's basically caught up. Yeah, 42. Wow. Wow. Oh. Okay, that looks massive. That looks like a storm. Yeah, that looks like a good-sized storm. Let's look at that. Let's look at surface temperatures and precipitation. Okay, let's see. That definitely is going to be like, you're probably going to have a coastal surface low like northern North Carolina, like on the Cape Hatteras, and even a little further north. Stronger system, still a little further north. Wow. Well, not really wow, but like definitely further north here. Okay, let's look at 500. So there's still a possibility of this storm, of this system wrapping itself up and basically having the storm go further north. Let's look at 6-hour. Let's look at 24-hour KPF at this time for 18Z. Or even 6-hour QPF. And then bam, further north. Still showing it going further south, but oh. Okay. Definitely further north this run. So yeah, it still not but if that trough goes further north, if that 500 millibar trough, that cutoff low, just goes a little bit further north, that could possibly shift the angle of attack right into New York City or closer to New York City. So you definitely want to look at that 500. You definitely want to look at upper air. Oops. The thing is, that is a major change. That is a huge change from the 12Z to the 0Z. That is a major change, and it's further north too. See, there's a little bit of a trough, and so it's kind of trying to go up here. So yeah, there's a little bit of a trough trying to. Okay, let's look here now. Now we gotta wait for the 3Z to come in of the wrap. Sorry, the 6Z of the wrap. Yeah, should be another hour. This is the trough that's basically going to form the coastal storm. Let's see how deep it is. Sorry, not the wrap. I was looking at the SREF plumes. Atlantic. That is probably going to be a major change. Wow, yeah. You could probably see that. Why, right? Still. That's one model that kind of changed. And then suddenly, oops, not the dam. Oops. So yeah, they lately so let's look at the other European run. Let's look at hour 78. Here comes the storm. And bam. Six-hour QPF, right? And then bam, right into New York. I mean, this is such a quick hitting storm. I mean, it's literally out of here in like just hours. So basically the last of it ends at hour 150. And it starts right around hour 38. This is like literally a 12-hour storm. There's a precip type rate. So 6 hours later is basically when it hits its crescendo, its peak. And then 6 hours later is when it's just, ending, sorry. So it's like, storm will literally last just about 12 hours. A 12-hour storm that would put down basically just, yeah, but that's the 12Z run. Let's look at the 18Z. I mean, you got a midnight run. In the last winter, there was a storm that came really close to giving New York City a lot of snow, but it went mostly west of New York City. Let's look at the National Snow Ice Data Center SeaGraph. That's actually pretty good. 2020, better than 19, better than 18, 17, 16, 15, close to 15, 14, so close at, so better than 13, so basically, okay, 11, doing better than 11, or about the same. Better than 2010, better than, or just as good as 2009. Better than 2008. Actually, that means 2002 ain't doing so bad this year. Let's look at the Antarctic though. That's where I am a little concerned. Yeah, Antarctic is on a very, very, yeah, so not as bad as 2018 though. Hopefully we can recover in Antarctica as well. If only we could have did like what happened in 2015, or sorry, 2014. That would have been great. Oh my God, that would have been great. Yeah, but you had a lot of positive. Yeah, the AAO was basically positive that whole winter. That whole winter, the Antarctic Oscillation was very positive. Well, winter for them. Basically, that's the summer. And you want to have a stable oscillation. You don't want to have all these constant flips either. Positive AAO is good. Yeah. When we hit the record CIs, it was right around 2016. And usually high CIs is correlated with, usually high AAO is correlated with higher CI concentrations, usually, but it has to happen in the winter. So let's look at the European again. Let's go back and look at there we go, the European model. Here comes that Colorado low, basically. Basically in the same position. Let's look at 12Z and compare now. Oh, that looks different. Okay. Oh, sorry. Wrong model. Yeah, make sure I do not hit 18Z. Oh, come on. Let's look at surface. Look at that. Easterly winds. Precipitate rate. Yep. So there it's starting. It's starting to form. Basically the Rockies low translates into a coastal low here, right? 2012. Lower pressures. So a stronger low, basically, stronger system. This happens It could also mean that New York City could get more rain or warmer temps because of the further north position of the system. Yeah. What in the world is this stuff here? Yep. Thank you, Timothy, for staying with me. All right. Let's look at the euro. I like doing that. I like staying. Yeah. I watch a lot of anime when I'm not doing weather videos. I'm just binge watching Dragon Ball Super right now. Yeah, maybe when I'm not doing a weather video, I could also maybe do a binge watch. Yeah, basically there's some bot accounts. Those are basically bot accounts. Those are not spammers, though. Those are just bots that sometimes get into live streams. Or just, I don't know. Anyway. There we go. This looks interesting, guys. Very, very interesting. So the system is further north in the last run. Let's look at midnight run yesterday. This one had rain for New York City. But the difference with that run and this run is, let's look at the amplitude of the trough. Amplitude yesterday with last night's run was very sharp, so basically indicating that warm air was going to be coming into New York City. This time the amplitude is not as sharp, but it's still indicating that some warm air could try to make it into New York City. So it looks like an average between the 18s, like last night's run, and the current run. So the 12Z is kind of like, I think this is going to be an average between this run and last night's run, basically. So an average between this run being further, south or north, and this run being further south. So it's kind of like averaging out a little bit. So let's look at last night's run, see where it was, all the way in Virginia, West Virginia, while midday run was more so further south. So it looks like somewhere in between. Even though it looks like it's going to be going further north, it is also showing that there's more cold air in place. So I do ultimately think it's going to end up going off the Jersey Shore. Yep. Now look at that. See, it does look like it's going to be rain, but keep in mind, the GFS is saying it's going to be all the way off the coast. And look at the warm air. So less warm air again. So as again, I'm saying an average between those two runs, basically. Okay. While I'm waiting for the Euro run to load, let's look at the GFS. Vorticity. Let's look at the vorticity. Oops. For the mid-Atlantic, for the continental United States. Very fast moving. Everything is moving very fast. That's a Friday system, right? Basically. Keep in mind, this is the 18Z run. So the midnight run showing a stronger system again. That's a big piece of energy. But that's like towards the middle end of January. And then look what the euro look what the GFS is showing. And yet your euro is showing it's from being an inland runner, so it's like you got to pick something between probably the closest storm that's going to be going up the coast. Again, looks like rain. Yeah, unfortunately, this current run is showing rain. Ugh, euro. Again, messing up with the position with a winter storm. I seriously think that the HRRR is more accurate in my opinion. Oh yeah, it's going to give me Chicago. Chicago. Yeah. Here comes that coastal system again. Let's look at the southeast. Right now you want to look at the southeast because that's where the storm is basically forming. It's basically forming somewhere along the southeast. Looks like central Georgia. Just want to look at hour 23, again, central Georgia. You again want to look at mid-Atlantic, and this is where it's going to emerge. But the thing is, you see how it looks like it wants to go up the coast and then it just kind of just shunts westward? That, to me, looks just really, really unlikely. It should be 36 here. See? Yeah, 36. The agency actually had more of a system trying to go further north. NAM. Let's look at the NAM again. Thing is, the 6Z comes in about usually 2 a.m. So maybe I'm going to stay up for one more hour just to see the NAM. NAM usually comes in right around 2 or 3 a.m. So I'm going to stay up until around 3 a.m. Then I'm going to go to bed. Because I want to make sure I see all the models as they come in. Just want to do one more cycle. No, I'm not, and I'm not staying up for the GFS. And I am going to leave the live stream running, but this time no one's going to touch my computer, so I don't have to worry about anything like what happened last time. Problem is I don't have a door to the kitchen, and I can't have my computer be in my bedroom because the Wi-Fi doesn't reach there. So it's in the dining room. Not the living room, the kitchen/kitchenette dining room area, basically. Oh yeah, I didn't really see the SREF. Yeah, this model is supposed to update itself really shortly, like next half hour or so is when the SREF plume should update. This is what you really want to look at. And again, it's probably going to windshield wash a little bit. It's probably going to shift further south, and then probably for the 9Z, it'll probably shift a little further north. So at the moment, I've basically looked at everything. Let's look at the CFS, basically the climate model. Yeah, that's showing the storm. 850 millibars. And yeah, looks like a storm is definitely possible. Storm, you know, cold, very cold. Wow, that is like, yeah, we're going to be in some Arctic air. And then probably warm up is going to happen. You know, we're going to have a January thaw. It looks like it's going to thaw and then nope. Like it's going to thaw and then it's going to go no, and then it's going to, yeah, it looks like very roller coaster, just a very roller coasterly winter. So a lot of cold air. It looks like cold and warm. So it's going to be warm here. It's going to be very cold up here. It's like northernmost Canada, United States, going to be some very cold temperatures. This is going to be some bitterly cold coming in. And then brief warm up right here. And then it's going to get warm and then it's going to get cold again. And you're going to, you know, yeah, the coldest is definitely going to be the beginning of January. Not too bad for February. So it's going to get warmer though. So here comes that cold blast, and then it's going to get warm, and then it's going to get cold, and then it's basically going to be cold throughout. Yeah, so definitely a very cold winter. And again, it crashed again. All right, it keeps on crashing. So yeah, this is how close I'm going to be basically to the RIT GPS station. So Rio de Terra is Rio de Terra, I believe, is a basically a place. Did they let anyone go there or no? Probably not. It looks very like secure type facility. And yeah, that is a gate that's probably going to close as soon as someone tries to walk through it. Yeah, this is not a place for anyone just to visit. It looks super secure, and like I think the only way in is like you probably need an invitation or something. See, even here. Yeah, it's gated. There's literally no way in, I think. That's a train station, basically. This is the official Yeah, looks like yeah, you can't just enter. Yeah, so what they're suggesting is basically, yeah, they're basically suggesting a walk that's basically impossible to Still waiting for the HRRR. I'm just trying to plan a trip to see a volcano. Yeah, I'm going to a volcano basically. Yep, there are some issues right now. Yep. Still down. Oh, great. Oh. Yeah, we had a pretty high case count yesterday. New York City hit 84,000 cases, so New York State hit 84,000. Of course, a lot of states did not report because it was New Year's, so yeah, my area basically has 14,000 cases. I'm basically one of the hardest hit areas right now. The thing is, half my family had COVID just from this. It was very mild. Omicron is very mild. I'm going to be honest. Omicron is basically like a cold. Here's the thing. I had a cold last month. Well, at the basically middle of November, end of November. I thought I had COVID or the flu. It was really bad. I thought it was either, I thought I either had Omicron, but then when I saw how high my fever got, I said, oh, probably it's Delta. But I didn't have any other symptoms besides a runny nose and sneezing. But I had really bad body aches and a high fever. Well, high fever for a cold. And I did turn on the heat in the van, which probably raised my body temperature a little bit. Because I was having chills, so I turned up the heat a little bit and felt comfortable. But that's when my body temperature just jumped through the roof and I went over 100 degrees. I was warming myself up though, to be honest. But yeah, it did hit 102. And then when I went into urgent care to basically get seen, they saw that I definitely had a fever. Actually, I went to the emergency room, my bad, not urgent care, emergency room. They said that my temperature, it went back down, because I took some ibuprofen, it went down to about 100 from a peak of like 102. And they tested me for COVID, they did a viral panel, it came back positive for common cold. Yeah. I just had a really bad case of the common cold. And here's the thing, usually with common colds I get a lot of coughing and phlegm coming out, but I didn't have that. I didn't really develop a cough. It was basically just a runny nose and fever. It was just runny nose and fever. Basically, a lot of sneezing too. And a bit of a sore throat, but I also have tonsillitis, so yeah. Well, look at that. Staten Island is actually not doing so bad. That's Staten Island. It's actually one of the boroughs of New York City. Only 3,000 cases. Wow. But the real... So it's Brooklyn, Queens, Manhattan, Bronx, and Staten Island. I mean, look at Bronx and Manhattan. They're not doing too bad. I mean, they're having a high case count, but nothing compared to Queens and Kings. I mean, Kings and Queens are basically taking the cake. You know, like... But since Omicron was dominating everything, we actually had more deaths before Omicron. So, yeah. Omicron is definitely, how to say this, preventing a lot of people from getting Delta, which is far worse. I would say this probably has mortality rates similar to the flu, seasonal, maybe a little higher than the seasonal flu, but because a lot of some unvaccinated people have died from Omicron, like people with underlying health conditions. Like, it's not that there's been zero deaths, there's been some deaths. Yeah, where do you use this Desiree? It's not great. This is good. This is good news. So Omicron is basically, it's basically a blessing in disguise. It's basically a blessing in disguise, so to speak. You had all these variants that were getting, more contagious, more dangerous, like what happened in Russia. Like, let's look what happened in Russia as a good example of how dangerous the Delta variant truly is. Let's look at cases. Probably alpha variants from other variants, but most likely alpha, right? Your alpha variant, basically. And then came the Delta variant. But keep in mind how you have more cases here, averaging of 28,500, peaking almost 30,000, 29,499. And then here is your Delta wave, which hit in the summer. This is basically a Spanish flu type event. Not a lot, 5,000 less cases per day, but let's look at deaths, right? Boom, they literally go off the charts right here. They just blow up. And you're having over 1,000 deaths. So you're having about 1,200 deaths per day, yet only 39,000 cases. That is literally a 3 to 4% mortality rate. The Delta variant had a huge spike in deaths. Here you didn't have a huge spike, but also the Delta variant did kind of come in really suddenly. But the thing is, in India, it was far worse than anything. This is the Delta variant. Let's look at deaths. This is just tragic. The thing is, you probably had, more likely the Delta variant probably killed several million people. And there's your beginning of your Omicron surge in India. Let's look at last 2 weeks, basically. That's the Omicron surge. I would not worry about Omicron. India has basically ridden its Delta wave, and now the thing that basically caused such a global catastrophe, basically, is being wiped out by Omicron. And hopefully, just hoping that no more dangerous variants come out of this. Because we also may have to be worrying about the bird flu. There's been a lot of talk about the bird flu. This could be the major pandemic for 2022. Yes, that has really been making the news lately. Yeah, they're talking about, yeah. Oh, it's not just Israel that's been affected. So anyway, yeah. There's been talk about bird flu as well. Of course, the bird flu right now is not really human-to-human transmission. You can only get it from birds. But the thing is, the Spanish flu, which actually started in the U.S., did not start in Spain. In fact, the only reason we call it the Spanish flu is because during World War I, Spain reported diligently on the Spanish flu because it was the only country that did not have any press censorship. It did not have any press censorship during the war. And of course, the king of Spain got sick with the flu, but he survived. But unfortunately, millions of Spaniards died. About 4 to 8 million died in Spain. And it happened during the summer. It was basically many times worse than the Delta variant around the world. But of course, in India, people died more longer. It was more of a prolonged death. The Spanish flu, it was more of a quicker death. It was within a day, people died from basically internal hemorrhaging. In some cases, sudden pneumonia. It was a very, very brutal way to die. It was not just suffocate. It was not basically. It was basically sepsis-like symptoms. Some people had organ failure because they had septic shock-like symptoms from a cytokine storm. Some people had temperatures of 107, 108 degrees, and reporting of joint pain so bad that people thought their bones were breaking. So people thought it was dengue or something else or some sort of chemical warfare. People did not know that this was just a flu. But it wasn't just a flu. It was extremely fatal to people with healthy immune systems. The ones with the healthiest immune systems were the ones that suffered the most. Because basically, the flu, the overimmune response caused cytokine storms that basically ravaged people's bodies. This overimmune response is what was responsible for a majority of the deaths. Other deaths were caused by secondary bacterial infections, which are common with the flu. But most people did not die from secondary bacterial infections. They died from a cytokine storm, or basically sepsis-like symptoms, where you have extreme inflammation, which causes your blood pressure to plummet. Yes, and some people were even having bleeding, internal hemorrhaging, or even external in some cases. So it did actually kind of turn into a hemorrhagic fever in some people. The fever became so bad that some people had hemorrhagic fever from a respiratory illness. Very unusual. Let's see if it's updated. Looks like still not. So I'm going to try the SREF plumes now. Let's look at the SREF plumes. And that's Storm Prediction Center. There we go. Looks like still waiting for the 3Z run to come. The 3Z run still has not come in. Should be coming in shortly. Let's look at latest earthquakes from Campi Flegrei. Okay. Looks like that. A little bit of an earthquake there. Probably hydrothermal. Does not look magmatic to me. Let's look at another Campi Flegrei. Definitely visible in others. Okay, it's only visible in 2 stations. Tiny little quake there. Definitely, that looks more like a harmonic tremor, but it's very short duration, probably hydrothermal. Could be the influx of magma that was caused by this little quake. I'm not really sure, but a lot of little tremors there, here and there. That's not very concerning, but you don't want to see this on you don't want to see basically a constant harmonic tremor. That's what you definitely do not want to see. See, it's quiet on everything else, which is good. It's probably very local hydrothermal activity. See, it's Solfatara. Solfatara. So pretty quiet other than that. Okay, that is Vesuvius. That is a big quake. Wow, that is pretty big. I would be a little concerned about that, especially since it looks like there's some magmatic activity associated with that little quake. Yeah, that was a big quake. I would say that's like a 3, maybe a magnitude 4. That is a big quake. I've never seen something like this at Vesuvius. That is probably the biggest quake I've seen in quite a while. Wow, it's visible on all of the seismos. So this is not like a little, that's probably, I would say that's a magnitude 3 or 4 at least. Alrighty. And now I want to look at what's going on. Vesuvius. Now I want to look at quakes. Sismolat, that's the one. That's what I want to be looking at. Bingo. Let's see, that probably was that 1.8 maybe? I think that's the one I was looking at. Yeah, the 1.8. Wow. I'm surprised there's nothing else that's more major. That is probably huge. There's no way that was a 1.8. That can't be. There's no way that was a 1.8. There's just no freaking way. There's no way. There's just no freaking way. So it's Sismolat. Now I know what to do. All I had to do was click on seismic localizations. Not gossip is basically. Okay, let's go back to Campi Flegrei. Of course, the current state. That's what I want to go to. Is current state or monitoring? Okay, monitoring. That's what I should. Monitoring. Seismological. No. I think it's surveillance. Oops. Wrong one. Fields Flegrei or Campi Flegrei. There we go. There's for Campi. Wait, I clicked on Campi Flegrei, not Vesuvius. Ugh, I want earthquakes for that area. There we go. What? Are you kidding me? There we go. Finally. Finally. Jeez. There's been a small uptick, looks like. You had a good 1.7 there. Let's just quick. That's, I think, the Salta Tower one. Monte Nuovo, I believe, is. There's Monte Nuovo right there. This is basically the caldera boundary here. Right there, the caldera boundary. Little volcano there. There's the caldera boundary. Let's trace it out. That's a big caldera. I mean, that is huge. And you also see little craters. It almost looks like craters. It looks like just a bunch of little craters all over the place. So it's not just a caldera. It's what I would call a complex volcano. Caldera/complex volcano. Because you're not having, overlap. You're not just having overlapping calderas. You're also having, And this is not a soma type volcano. This is a caldera/complex volcano. So a lot of earthquakes, a lot of small earthquakes every single day. 28, 29, 30. Here we go. I think now it may be time to look at a volcanic field that has been active for more than 80,000 years, with several volcanic centers located in and near a depressed area called a caldera. The caldera is the result of repeated sinking of a large area caused by the collapse of the roof of the surface magma reservoir, magma chamber, following its emptying by at least two major eruptions, the Campanian Ingham-Bright and the Neapolitan Yellow Tuff, 15,000 years ago. The Ingham-Bright Campanian Ingham-Bright eruption is the highest energy eruption known in the Mediterranean, with an enormous amount of ash was dispersed in the atmosphere. Global, wow. Tough cone. It's a tough cone. So basically, so it's not a cinder cone, it's a tough cone. Wow. Now, let's see if it's going to be working now. Looks like it is. Okay, let's see. Okay, SREF. Still has not loaded yet, which is a little unusual, but let's try SREF plumes. Maybe it's updated. Nope, still has not updated yet. Thank you for bearing with me. So let's look at the HRRR now. Ooh, yes, the 660 is coming in. This is the big one. This is the one that's gonna basically determine. Alrighty. Okay, hour 12. Hour 12. Precipitation height. Yikes, that looks a little bit like. Wow, there's actually going to be some snow in Atlanta. Atlanta actually might get a little bit of snow. First time in a while. Nice. So Atlanta might just get a touch of snow. I'll be right back in just a minute. So let's look at the HRRR. This is the. So let's look at the gem. I'm sorry. Mm. 48. 42. So right on the coast. It's like a really close call, but like not much. Oops. Oh. This looks rather interesting. So low forming here. Okay. 2008 forming right around let's see. There we go. It just updated. The struct plumes have just updated. Perfect. let's look at the the 2022 January 1st, 2020. See? 2022 January 1st. Sorry, 3-hour TPF. Whoa! Whoa, 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 whoa. Okay. Jesus Christ. Oh, jeez. Alrighty, that is quite a bit of Jesus Christ. What in the world? Snow. Total snow. Oh my God. Mean was right on 2.78. Jeez, that is a major change. Yeah, that is major. Yeah, this is the old run. Ugh. All right, there's basically been a major increase in snow. Okay. So, okay, 19 inches. Mean is 2.78, and now the mean is about 5 inches of snow. Let's look up. Let's look at Philly now. 10 inches. Let's look at Atlantic City. 28 inches of snow. Inches of snow. Let's look at Poughkeepsie. Oh yeah, some of them actually showing rain. ARN3. ARN3. ARP2. ARP2. Let's get rid of all the other models, right? ARP2. Let's do it. Let's get rid of all those other ones, right? And I just want to leave ARP2. Boom. I want to get rid of all the ARN models. ARN, ARN. ARP. Just want to leave it. Anything that's ARP, I want to leave it. ARP2 shows 15 inches of snow. Let's reset it now. Now the mean is like, there's one model that's turned up to 19, but it would be 4. Yeah, it's definitely trending for the north now. So this is like Poughkeepsie area, having a mean of between up to 19 inches. So you're having 1, 2, 3, 4 miles. Oops. Wow. Like literally 1, 2, like almost nothing. Okay. Let's see what the HRRR is going to do now. Wow, there actually might be some severe weather with this. Looks like the storm is in about the same position though. Looks like it's still going to do what it did before in the earlier runs. So 31. 26, let's go to 32. Let's go now. Now let's check the mid-Atlantic, basically. Simulated reflectivity. That is, yeah, that's a lot more precip now. Basically, as soon as it hits, it's almost showing as soon as it hits North Carolina, it just basically elongates itself and then it goes east. But see, you see how this line right here, 46 here, but now it's boom further north, right? Wind gust. Alrighty. Why can't I go a little further north? Make that left-hand turn, like. Yeah, why can't I make that left-hand turn? Ugh. Yeah, of course the HRRR isn't the most reliable, but. Wind gust. Let's look at wind gusts. Yeah, but this should have a lot of moisture with it. Which means I should probably, let's see, this is 9 a.m. I should probably leave like 6 a.m. in the morning. Definitely a little further north, but not by much. Though a lot can still change. I mean, see, at 18Z, center of the storm was further south. Simulated reflectivity. Look at surface visibility. Yeah. That much of a cutoff is not very likely considering how warm the ocean is. I just don't think that's very likely. You're not going to have suddenly nothing and then boom, blizzard. This one is probably going to go further north. As soon as this hits the very warm water, boom, it's just going to blow up, especially with all that cold air, cold water here. I mean, warm water you know, cold land, warm water, it's gonna basically feed right off of that and just blow up basically. Gust. Doesn't show a lot of snow for New York, but 6-hour precipitation accumulation. It's a 12-hour. Or let's look at 6-hour. Yeah, imagine if that doesn't happen. Imagine if it actually kind of continues to go further. Just imagine if it continues to go further north. And yeah, that's some light snow coming into New York City according to this run, but something just isn't right with the position of the storm and how little precipitation is falling on the north side, considering how warm the ocean is. It just doesn't make sense. I mean, okay, the storm is pretty far off the coast. I'll give you that. But considering how warm the ocean is, there's probably going to be a lot of more moisture than what this model is showing. It just, and this, like going north and then suddenly just going east and then go back north again, that is just honestly kind of hard to buy. Lots of humidity. It looks like some light snow in New York City. Not much. It looks like about, say, an inch or so. But look at that. Oh, jeez. 14 inches in... My God. Now I'm probably going to have to be looking at ways to get to like Atlantic City, because Atlantic City looks like it's going to be really close to being the bullseye zone. Or I could just go to Philly and then Philly to Atlantic City. Greyhound, everything's Greyhound. And Tom's River. train that goes to Atlantic City from Philly. I'll be right back, hold on. I'll probably have to leave early in the morning Monday, like really early, because the train from New York City to Philly, let's go to Penn Station. Oops, other way around. Let's switch directions to Atlantic City, New Jersey. Market Transit Center. Greyhound? No. Let's say I leave at 4 a.m. Northeast Corridor, which is at 5 a.m. Riverdale Light Rail. Yeah, it's about $1. It's about $1 or $2. It's a bus 551. So I'll be there around 9:17 in the morning. So about a 4-hour trip. It's probably not the fastest way. Atlantic City Rail Line, Cardinal, 3 hours. Let's see. Cardinal 6 foot. Let's see. Lakewood Bus Terminal. Oh wait, I'm looking for Monday. Yeah, Monday, January 3rd. Probably different schedule. That's way too, like, let's go to Transit Center. Princeton Junction. Northeast corridor, 7 a.m. Any corridor. Schedule. January 3rd from Penn Station to Trenton Transit Center. Check schedule. Yeah, you don't always want to go by what the Google Maps is telling you. You always want to check the schedule. And look at that. Ha! 5 a.m. There's a 4 a.m. train. Really? You gotta be kidding me. Seriously? There's a 4 a.m. train? There's a basically train almost every hour. And it's only, for me, it'll only be 7:65. Not bad. Not bad. And then to Atlantic City. Let's even say Atlantic City Rail Terminal. And let's see. Oh. Let's go to Philadelphia. So right there at 7:17 a.m. Yep. So let's go from Philadelphia to Atlantic City, New Jersey. Huh. Hour 46 minutes. Let's see what time. 7:15. Not bad. That'll be so right there at, let's see. At 7:17. So I definitely need to get on the 4:17 train. Or eight stops. So basically it makes 8 stops. So there's 8 stops along the way. Which is pretty nice. First and basically only stop. There's one of the stops after. I might, I don't know, stop off somewhere there. Atlantic City Rail Line schedule. What the train looks like. It probably looks like some sort of diesel, yeah. That's what I was thinking. Yeah, so it's a diesel. And why am I going there? That's basically my case plan if the storm ends up going further south than expected. I might not even have to. I mean, let's look at this. 1 inch plus snow. Kind of showing that there's even a chance that the storm could, wow. Yeah, foot or more. Ah, look at that, right over New York City. That foot or more chance, right over New York City. Just unbelievable, wow. Foot or more, just bullseye almost. Yep, kind of bullseye right over New York City. I might not even have to go anywhere. I mean, it looks like that storm might end up going further north. So it looks like all the other models are going to have to play catch up, or this model's going to check back further south. Let's see, 1+ inch. Thing is, they're saying more chance of 1+ inch. When you're looking at 12 or 8+ inches, very good chance basically 10 to 20% chance. So there's about a 50% chance of 8+ inches and a foot or more. Greatest chances New York City southward. So yeah. And it's only 48 hours out. I don't think the National Weather Service should just jump the gun and say, okay, Winter Storm Watch yet. Definitely a Winter Storm Watch should be issued for like New Jersey. But New York City, it's a little too early to tell. Like, it's way too early to say, oh yeah, let's say Winter Storm Watch for New York City. But I would issue one for like southern New Jersey. Let's see that the National Weather Service has already realized that something's going to happen in New Jersey, and nope, they still have not realized it yet. Plus, there's still a tornado watch in effect. And there is a bunch of freeze warnings, basically. Hard freeze watch. Poor Dallas. Damn, they're dealing with another crazy cold blast. Dallas current temps. "23 freaking degrees. Unbelievable. Ugh. Alright, I'm gonna... cold in Dallas. I mean, that's freaking cold. Oh, great. Well, SREF blooms are definitely showing a good storm for New York. Basically, the NAM should just be coming in now. Should just be coming in. And there it goes. It's just starting to come in. Of course, this is an 18Z run, so this is not, I mean, this is not a, how to say this? This is not a 6Z run, so you can't really rely on it that much. So whatever this run basically says or does, just take it with a grain of salt, basically. That's all I'm going to say. Take it with a grain of salt. Even if you see something you really want, I would say just, like, don't just buy it. Say, oh yeah. You gotta, like, wait and then, you know, if you see something you want, like, thing is in meteorology, there are times where you're going to be really disappointed or really happy. I mean, it changes. I mean, look at this. Parts of northeast Mississippi are going to get snow. How cool is that? That is really unusual. It only happens a couple times a year, or sometimes it doesn't even happen at all. It's very unusual to get that much snow in Mississippi. It's like really unusual. It's more common that you might get snow. Maybe in Tennessee, North Carolina, northeast of Georgia, and very rarely maybe northern Louisiana and Arkansas. But the thing is, this maybe happens a couple times a winter, usually in January, February. This is basically as rare as it gets. From my understanding, I do think that this run will also have not much snow. Why I'm thinking this is because look at the zonal flow, right? Look at the flow. This is the piece that we try to pick it up, see how it. There's a little piece of energy right there. It's barely noticeable. See a little kink right there. Basically almost in the same exact position. See, here's a west, like, oh, kind of trying to go west here. So you're going directly west-east here, like just straight. But the earlier run had it going, yeah, I don't really see much change. In fact, this may actually be in the same position. what you really actually want to look at is actually the 500 millibar vorticity. Let's look at the vorticity. Much stronger. It's actually stronger. They're showing a much stronger vorticity. Or is this just an 18Z kind of thing? Yeah, it looks like it's a kind of an 18Z kind of thing. There we go. Yeah, look at that. That actually looks really impressive. So it is in the same position though. But looks like Northeast Georgia kind of. He's in the same exact position too. I'm with you. Look at that. Same exact position. Yeah, the low is basically in the same position. There's been hardly any change from the last run. Only difference is there's a little bit more precip on the north side. That's basically about it. And based on that, it's pretty safe to say that I'm not sure if the cutoff will be that strong, but probably, yeah. Vorticity. Vorticity. So it should probably be based on the last run. I would say probably in a similar position, maybe even a little further south. So right on North Carolina, South Carolina border. Even a little further south, actually. What's a little impressive is that little 551 line. Yeah. That's what I find a little surprising is this. It's actually stronger. That wasn't there. You didn't really have that. This could also present its own set of problems. this thing ends up being stronger than forecasted. This could also present its own set of problems, such as storm going further north or being a little stronger. I don't know exactly, but looking at the vorticity, so that's 700. Wow, look at those stronger winds. Five, 5, 1, 0, and then it's like, so it is weakening, but much slower than what the other models had. Wow, that is a little bit unexpected to be kind of going that far north. Into Virginia? Come on. Let's see, 36 or 39. See, it's kind of going west-northwest. But here, yeah, there's definitely some change in the position of the storm. It does actually look to be further west, and there to be heavier precip. So yeah, this could be, like, this looks like it kind of wants to, this could be a major system. See how that is just knocked like that? This is going to definitely you see how you're having that inflow, like almost like an inflow notch? Vorticity. This is what could enhance them. Look at that. Look at those really strong vorticities. Wow. But because it's so wrapped up, yep, going right into the Delmarva Peninsula. Instead of going further south, it goes further north. Here, it really looks like it just wants to go further north. And yeah. Yeah. Let's look at zeros. Bingo. And again, further north, so 6 hour accumulation. again, if this indeed happens, there could be some major snowfall right along the coast. Major snowfall. And imagine if the storm makes a left-hand jerk and ends up going further north. You're going to be having crazy winds, like just... Maybe... The storm is definitely going bombogenesis here. 690, 660. So, yeah, so it's definitely strengthening. Vorticity. Come on. Yeah, this definitely looks pretty interesting, to say the least. Yeah, SREF plumes are definitely showing a trend further north. The mean has been definitely higher. Oops, did not want to close that out. At least I'm going to leave those two windows open. Because I'll have to leave my place on like... Transit Center. Hmm. 30th Street, Philadelphia. Yeah, I don't think that's a good idea. I think my best bet would probably be 554. Yeah, I think my best bet is probably... Bam. Definitely looks like a pretty strong system. Ah! This is midday, 11 a.m. This is 3 a.m., 4, 5, 6, 7, 8, 9. So wrap is showing basically. Of course, the wrap is basically does it. I'm not a bad everyone. Thank you for watching and good night.